Chapter 5, we're going to talk about angles, degrees, radians, the unit circle. We're going to solve trig functions. There's a lot to do here in Chapter 5. But today is just really basic, kind of a geometry reminder about what angles are and stuff like that. But when we talk about angle measure, right, every angle that we're going to talk about has an initial side and a terminal side. What does the word initial mean? Initial is where it starts. So initial is your starting angle. Hang on. All right, initial is where it starts. And what does terminal mean? Where something what? Ends. All right, we're going to talk about positive and negative angles. But your angles that we're talking about right now are always going to start on the positive side of the x-axis. Okay? So if we're talking about a coordinate plane, it's always going to start right here. A positive angle is measured up. A negative angle is measured which way? Down. Right? If you have a positive angle measure, it'll be like this, like 47 degrees. That means from 0, you go up 47 degrees. If you had an angle measure that was negative 25 degrees, you're starting here at 0 and going downwards 25 degrees. So the only thing that that negative sign does is tell you direction. If it's a positive angle, you start at the x-axis and go up. If it's a negative angle, you start at the x-axis and go down. If we talk about different quadrants, right, in a coordinate plane, what is the first quadrant? Right here, correct? What are the signs in the first quadrant of x and y? Positive and positive. If I was at the origin telling you how to go to a point in the first quadrant, you'd go right and up. This is the second quadrant over here. What are the signs of x and y in the second quadrant? Negative x, positive y. This is the third quadrant. What are the signs? Negative, negative. And then the fourth quadrant. What are the signs? Positive, negative. Okay, good. All right, that's just a little refresher for you guys to remember. Say it again. Yeah, sure. Hang on. I'll go back. All right, so initial, like we said, is the beginning. Terminal is the end. Rotation of counterclockwise is positive. Clockwise is negative. What I just said to you, what I just drew you, if you have two coordinate planes, and I'm talking about a positive angle starts at the x-axis and goes this way. We always think of it as going up. A negative angle starts at the x-axis and goes this way. It's just the direction. So a positive angle, you start moving upwards. A negative angle, you start moving downward. Now, we think in degrees. All right, if I talk about a whole circle, we're just talking a lot of vocabulary stuff here. If I talk about a whole circle, if I talk about a circle, how many degrees are in one whole circle? 360. Good. So if you have a number that's more than 360, it's more than a circle. But we also have another measurement called radians, and we're going to go back and forth from degrees and radians. A radian measure is 360 divided by 1. It's 1/360th. Right? That's how we figure out about radians. That's the conversion. Now we're going to convert from degrees to radians and radians to degrees. We're going to give you a tiny little conversion factor, and it's going to be super easy. But we think in degrees. You guys are conditioned to think in degrees. You talk about degrees all the time. This is going to be a little bit different. You're going to have to look at some stuff. Now let's think about a coordinate plane. This is 0 and also 360, right? What's this measurement up here at the top? 90. What's over here on the far left? 180. Good. What's down here? 270. Good. So if I said to you my angle starts at 0 and is 90 degrees. This is a 90-degree angle right here, correct? If I said my angle starts at 0 and it goes negative 90, then I would go in that direction. Do you guys understand that? Yes? Okay. I want you guys to really pay attention to that. Focus on that. When we talk about a radian measure, right, your circle is cut up into 6 pieces. And each radian is just the hypotenuse of a right triangle. It's what it is it takes this and just kind of flips it. And again, I'll show you guys later on. You'll see that a little more. All right, let's move along here. All right, we just talked about this in degrees. Now we're going to talk about it in radians. 90 degrees up here at the top is the same as pi over 2. 180 degrees over here at the right is the same as pi. If you go 3/4 of the way around, it's 3 pi over 2. And again, we'll get into what this really means when we get into using our unit circle, and I'll explain to you exactly how this is derived and stuff. I want you guys to be able to think in terms of degrees and in terms of radians. Here is the conversion factor. This is not anything that you guys have to remember. You guys aren't like, oh gosh, I got to remember. I have to memorize this. You have to memorize that it's pi over 180 or 180 over pi. But when you're converting, if I start off in degrees, what am I going towards? Radians. If I start off in radians, I'm going to what? Degrees. So it's really easy to figure out how to do that. Let's look at letter A. If I'm going to say, okay, 60 degrees, what is that in radians? Well, think about it. I have 60 over 1, correct? If I'm going to convert 60 degrees to radians, what do I want to cancel out? The degree sign. So where would the 180 degrees go? On the top or on the bottom? On the bottom. There you go. If you think about it that way, guys, it's either pi over 180 or 180 over pi. It's whatever you want to cancel out goes on the bottom. So now you could use your calculator. Right now we're not going to. I know right away that 10 goes into both of these, right? And my degree sign cancels out. What goes into both 6 and 18? 3, okay. 3 goes into 6 2 times. 3 goes into 18 how many times? 6 times, all right. Can I get it smaller? Yep, 2 goes into 2 once. 2 goes into 6, 3. So what am I left with? Pi over 3. 60 degrees is the same as pi over 3 radians. So if I look at my next question, it says express pi over 6 radians in degrees. Okay, so write down what you have, pi over 6. Let me do it, scoot it over. I have pi over 6, and I want to go to degrees. So what's going to go on top? What's going to go on bottom? 180 over pi or pi over 180? 180, good. You want the 180 on the top and the pi on the bottom, because look what happens. My pi's cancel out. Now, what number goes into both 6 and 180? 6, okay. 6 goes into 6 once. 6 goes into 180 how many times? 30. So you just made your conversion. Pi over 6 is the same as 30 degrees. Notice I put a degree measure. Got to have the little degree circle there, okay? Very important. So I have 2 more examples here. These are a little bigger. I have negative 7 pi over 12. What does that negative mean? It's the only thing that negative means. It's going to go down. The direction. When you convert, that negative means nothing. It stays with your answer. It's still a negative angle. But it's just telling you if you were to draw it, what direction you would go. So where does pi go and where does 180 go? 180 is on the top and pi is on the bottom. The reason pi is on the bottom is because you want the pi's to do what? Cancel out. So look, pi on top, pi on the bottom, they cancel. And now we just simplify. What number goes into both 12 and 180? Start small, 2, right? 2 goes into 12 6 times. 2 goes into 180 90 times. What's another number that I could simplify with? 3, okay. 6 divided by 3 is 2. 90 divided by 3 is 30, all right. Anything else? 2. 2 goes into 2 once, and 2 goes into 30, 15. So what do I have left? Negative 7 times 15. What is 7 times 15? So it's negative 105 degrees. That negative sign stays with it, and now you're in degrees. Now I look at 952 degrees. What do I notice about that number? It's above 360. It's way above 360. So your numbers, and that's fine. That just means you went around the circle a couple times. But this is 952 over 1. So what is my conversion? What's going to go where? Pi over 180. Absolutely, because we want the degrees to cancel out. So guys, use your calculator. Just go with 2. What's 180 divided by 2? 90, okay. And then what's 952 divided by 2? 476, okay. So 476 degrees. No, degrees canceled already, sorry. Anything go into 90 and 476? 2 again, right? What's 90 divided by 2? 45. What's 476 divided by 2? 238. Yeah? Okay. All right, 2's not going to go into those anymore. What about 3? How do we know if 3 goes into 238? Okay, add 8 and 3 is 11, plus 2 is 13. Is 3 going to go into 13? No. Is 3 going to go into 45? Yes, but it can't go into both of them. Can you simplify this anymore? No. So you are left with what? 238 pi over 45. You can also write it as 238 over 45 pi. It can be written either way. You guys understand the conversion? Not terribly difficult. A lot easier when you have a calculator. All right. When no unit is given, the angle is assumed to be measured in radians. Guys, if there is a pi, you're in radians. If there's a degree symbol, you're in degrees. You might have a question that says convert. And if it says 43 like this, you're starting in what? Degrees. So you're going to radians. You might have a question that says convert, and it says this. You're starting in what? Radians, going towards degrees. Okay, good. Make sure you understand that. All right, when we talk about an angle in standard position, remember that means the angle does what? Starts where? It starts at 0. Look at the difference between here, A and B. What kind of an angle is A? Positive or negative? How do you know? Because it went up. What kind of an angle is B? Negative. How do you know? Because it went down. Good. Very good. What do you notice about C? What did C do? It passed 360. So the measurement is going to be more than 360. Right? This is plus, this is over 360 degrees. What about D? Well, we started here. Did we go up or down? You went up, so you went around one whole circle and then some, right? And that's fine. This is still more than 360. That's totally fine. Again, if you had a negative 700 degrees, all that means is you're going here, you go the opposite direction. You go one whole circle and then some more around. It's just the direction. I cannot impress upon you enough, guys, about that. The negative in front is just the direction. From where you start, which way did you go, up or down? Ooh, I like that you just said that. Wait, hold on. Sophie said, what's the difference between A and C? This angle right here, I agree with you, is the exact same. We're going to talk about something in just a second called coterminal angles, which you're at one spot and you go around and you're at the same spot again, but it's a different angle measure because you added 360. Yep, good, very good. Look at coterminal. That's fantastic. Two angles in standard position, if their sides coexist, like in figure 5, A and C, those are considered coterminal. I want you to write this down. To find coterminal angles, you add or subtract 360 if it's in degrees, or 2 pi if it's in radians. Meaning, just like Sophie said, well, wait, what's the difference? Okay, if I have this angle right here, say I have this angle, and I tell you that this angle right here is 45 degrees. All right, you can find a bunch of coterminal angles. you can find a bunch of coterminal angles. You could go from 45 degrees if I added 360, right? If I'm right here and I add 360, don't you agree that I come to the same spot? All right, so coterminal is whatever angle you're given, you can add 360, and it's a new angle, but you're in the same exact spot. Or you can subtract 360, and it's a new angle in the same exact spot. You can have an infinite amount of coterminal angles. You could add 7 circles and be right back at the same spot. It's a different angle measure, but it's in the exact same position. So if you had something like this, find angles that are coterminal. These are really easy. Let's do these ones. I want to find 2 coterminal angles, one positive and one negative. So I'm starting off, letter C, I'm starting off in what kind of measurement? Degrees, okay? So in letter C, I want to find coterminal angles. That means I'm going to add and subtract what? 360. So I have negative 170 plus 360. What is that? What's negative 170 plus 360? How much? So 190 degrees. There's a coterminal. If you wanted another positive coterminal, what would you do? No, another positive one. Add another 360. But in our case, I'm just going to ask you for one positive, one negative. So now I'm going to say, what's a negative coterminal? I'm going to say negative 170 minus 360. What's negative 170 minus 360? Negative 530 degrees. Perfect. All right, what do you think would happen? I'll do letter D in a second, but what do you think would happen if I said, okay, I have 390 degrees. My theta is 390 degrees. I want a positive coterminal angle, so I'm going to add 360. Guys, when you add negative 390 and 360, what do you got? Negative 30. Is that a positive number? No. So what do you think I should do to get a positive number? I'm going to add it again. You keep adding 360 till you get a positive, and then you keep subtracting till you get a negative. If you had a number like 900, and I said, what's a negative coterminal? You'd have to just keep subtracting 360 till you got a negative number. Now, letter D is a tad bit harder. Why is it harder? Because it's in radians. So it's the angle plus and minus 360. Well, 360 is the same as 2 pi. So I have 18, not 118. I have 18 pi over 5 minus 2, well, that's 2 plus 2 pi over 1. I'm adding a whole circle. Guys, how do you get a common denominator? Would be what? Right, 5 would be my common denominator. So multiply 5 by 1. So what you do to the bottom, you do to the top. This becomes 10 pi. So 18 plus 10 is 28 pi over 5. That's a positive coterminal angle. Start again. And I'm going to now subtract 2 pi. Again, common denominator. What's the common denominator between 1 and 5? So this becomes 5, this becomes 10. You guys agree? What's 18 minus 10? 8 pi over 5. Is that a negative? So what should I do? Subtract again. I'm going to subtract another whole circle. What's my common denominator? 5. So now I have, what's 8 minus 10? Negative 2 pi over 5. Is that now a negative? There you go. So do you guys understand? Coterminal angles, you can have an infinite amount. But what it is you take the terminal side and you just add 360. And you add it again and again and again. Or you can subtract 360 again and again and again. You just want to get one positive and one negative. You guys with me? Okay. Good job, good job, good job. All right. Length of a circular arc. Here's the formula. S equals R times theta. S is the circular arc. R is the radius. And theta is the angle measure that you're given. But what does it say, super important, about theta? What does theta have to be in? Radians. All right, so here's the thing. You guys are going to get a You don't have to worry about this. You're going to get a question. All right, let's look at A. It says, find the length of the arc of a circle with a radius of 10 that's sub 10's essential angle of 30. All that means is this is across from. So your formula is S equals R times theta. S is the arc length that you're looking for. R is the radius. Theta is the angle measure. But theta has to be in what? Radians. What did they give it to me in? Degrees. 90% of the time when you guys have a problem like this, they're going to give you the angle in degrees. So if they tell me that theta equals 30 degrees, what do you think I should do? If it has to be in radians, what do I need to do? I need to convert it. I need to convert this, put pi on top and 180 on the bottom. This becomes what? Pi over 6. Now you can do the problem. A lot of you will go like this. Okay, the radius is 10, the angle is 30, so my arc length is that. Is that correct? No, you have to convert. When you use the arc length formula, you absolutely have to have your theta in radians. You have to. So now when we do this, we get 10 pi over 6, which reduces to what? 5 pi over 3. Okay, now, if they ask you to leave your answer in terms of pi, that means pi should be in your answer. If they say to round to a specific decimal, everybody in your calculator has a pi button. You can hit 5 times pi, enter, and then divide by 3. Tell me what you get in 2 decimal places. 5 times pi divided by 3. What do y'all get? 5.236. So 5.24? 236, right?
It's like 5.2. Yeah, this isn't rounded.
Yeah, so that's rounded. And we're talking about meters. Depending upon what they ask you, if they say leave your answer in terms of pi, this answer is in terms of pi, or it might be written like this. This is your decimal. Do you guys understand the difference between that? If a question says leave your answer in terms of pi, all that means is leave the pi sign. You don't have to multiply it by 3.14 and then divide. Just simplify your fraction. All right, you see that? All right, let's look at B. B is a little bit different. Ready? We're talking about arc length. So S equals R times theta. What did they give me? Essential angle theta in a circle, a radius of 4. So they told me R was 4. Subtended by the arc length is 6. What am I looking for? Do I know what theta is? It says find the measure of theta in radians. So how do I find theta? How do I get that funny looking thing all by itself? Divide both sides by 4. Good. So I have theta equals, what does 6 over 4 simplify to? 3 over 2. And this is radians. It's already in radians. If you wanted to then convert, you'd have to do the pi over 180 to go back to degrees. But if they ask you for arc length, guys, your theta has to be in radians. If they ask you for the theta, you have to then read, does it say, how do you want it? In radians, then leave it. If they want it in degrees, then you have to convert. Make sense?